Hello, ladies and gentlemen. We are going to go over a practice problem that's in your skills packet. So this is in your skills packet, and we are going to be doing the very first problem that is looking at silicon. Okay, so make sure that you are there and you are following along and you're completing this problem with me. All right, so if we're looking at silicon, there are 3 different isotopes of it. And just to review, these numbers that are written behind the name, those are the masses of the isotope. Now, this particular problem, we're not going to be using this mass. We're going to be using this mass when we're doing our formula because we can see that it's much more precise with all of those numbers after the decimal. So in notes 3, we looked at the formula for calculating the average atomic mass. So we take the individual masses of all of our isotopes, and then we multiply it by the percent abundance. If you get your percent abundance in a percentage, you need to change it to a decimal. So the way to do the decimal is you take your percentage and you divide it by 100, because that's what a percentage is. When I divide it by 100, I have my decimal percent abundance. The shortcut is you just take your decimal point and you move it over 2 placeholders, and that will give you the percent abundance. It's the same thing as dividing it by 100. Okay, so I'm going to go ahead and do that right now so we can see all of those numbers. All right, so all we're going to do is we're going to take our mass, multiply it by the percent, and we're going to do that for how many isotopes we have. In this example, we have 3. So my first isotope, the mass, I'm not going to use 28. I'm going to use all of these numbers. So 27.97693, I'm going to multiply it by my 0.9223. This is the number that I get. Make sure that you store this in your Desmos. We don't want to round until we get to our final answer. I'm then going to go to my second isotope, 28.97649, and I'm going to multiply it by 0.0468. This is the answer that I get. And then for my third isotope, I'm going to take my atomic mass, multiply it by my percent abundance, and this is the number that I get. I add all 3 of those numbers up. I carry all of those numbers out. And then I want to look at my thousandths placeholder, and if it's 5 or greater, I'm going to round my number up 1. If it's less than 5, it's going to stay as an 8. So because it's 5 or greater, I'm now going to round this up to a 9. So the average atomic mass for silicon is 28.09. When I find silicon on my periodic table right here, I get 28.09. So that's my average atomic mass. Now this is how you do it the math way. Now you will have some multiple choice questions where you may not need to show math to get your answer. So I'm going to teach you a shortcut right now. If we look at our chart, we can see that silicon 28, that is the most abundant isotope. So if I had a sample of silicon and I were to pick out one atom, I'd have a 92% chance that it would be an atom of silicon with a mass of 28. So if I were to be guessing what the mass would be nearest, this would be a pretty good guess, that I'd be looking for an answer closest to 28. Given that my percent abundance is lowest for this higher or heavier silicon, I would not want to pick an answer that's close to 30. And we can see with our evidence here from our math calculations that my average atomic mass was closest to 28, specifically 28.09. All right. So this was just the first example problem. You have a couple of more that are in your packet, so please feel free to go ahead and practice those in class and make sure that you are asking questions if you're confused.